Hello everybody, my name is Ilifar Shahdouz. Recently I received my master's degree in artificial intelligence at the University of Tehran. Today I'm making this video for Neurmatch Academy teaching assistant application. Okay, today I'm going to talk about multiple linear regression and polynomial regression. Okay, let's run some prerequisites. Okay. What is multiple linear regression? Imagine that we have some data points, x1 to xd, and we have some labels or outputs of those data points, which is y. And we are going to fit a model to our data in order to just look at them, in order to visualize them better. How we're going to how we're going to find that model? First, we have to put our data points in a matrix like this. We put ones here because we want the bias term to be matrix multiplied by all of those terms, and we want to have that in our formula. So in order to find the thetas, we have to implement some mean squared error function, which is here. And the matrix formulation of a mean squared function is like this. So here in the following code, I'm going to implement this part. Okay, let's first uncomment. Let's just comment that part and then I'll uncomment these parts. And then I am going to find the inverse function, which is a function in the linear algebra of NumPy. And I'm going to matrix multiply x transpose to x. And then I have to matrix multiply it by x transpose again. And then matrix multiply it by y. Okay, first of all, I have to find some sample data points. And as we see here, we can see that we have a two-dimensional data points, which are x1 and x2. And here is our label. And we are going to fit a model on this. So let's just implement this part again. And there we go. We have our thetas here. And then we are going to take a look at our estimated plane, which is something like this here. When we can see here are our data points. Here is our plane, our predicted plane, and some little vertical lines are the errors between each data point and the estimated plane. Okay. Till here, we had some linear pattern between the input and the output. But what happens when we do not have a linear pattern? What we are supposed to do here is through some transforms, we have to change the input to some polynomial, higher dimension polynomials, and implement something like this. This can be called a polynomial regression. And then after doing this, we can apply the linear regression again, because we can increase the dimension of our inputs in order to just have a linear pattern between input and the output. So here I am going to implement this part. Here I'm gonna stack all the elements of the matrix. There we go. I can put some design matrix here. And x to the power of any degree. And we can run the code, and here we have the biases and our thetas. Thank you very much.